Hello friends, this video on aldehydes, ketones and carboxylic acid part 5 is brought to you by examfear.com. No more fear from exam. Let's take some more examples. Here we have to give the IUPAC name only. So as I told the first rule, this carbon chain gives the lowest number. So I'll start the numbering in this direction 1, 2, 3, 4, 5, 6 and 7. Correct. So I have my bromo group and methyl group are the two substituents here. So let me write bromo here and methyl here. Let's start. A, B comes first. So bromo will be given priority alphabetically. So it will be 4 bromo. The second is what? Methyl, 3 methyl. Substituent give over. Then I have 7 carbon. So it is hept, all single bond, ane, and this is aldehyde, al. So it is 4 bromo 3 methyl heptanol. Correct. Let's try this one. So here if you see, again aldehyde group gets the first number. Again number from here 1, 2, 3, 4. So in this case methyl group gets the 4th position. Or I can number in this fashion 1, 2, 3. Methyl group gets second position, so I'll number in this fashion 1, 2, 3, 4, 5. So the only substituents I have is methyl group. First let me add that. At third position, it is 3 methyl. I'm done with my substituents. Then I have cyclopentane. Let's make it cyclopentanone. So 3 methyl cyclopentanone. Let's take this guy. It's pretty easy. It's a cyclohexane with a CHO group. So it will be cyclohexane with the CHO's carbaldehyde. Cyclohexane carbaldehyde. Let's take this. Numbering starts from here 1, 2, 3, 4, 5. Now at there is no substituent 1, 2, 3, 4, 5 carbon, so start with pent. At 2 I have double bond pen to ene. At 1 I have aldehyde group, so I can say pen to ene 1 all Al or just you can say L. So this becomes pen to enal. That is 1, or you can have 1 also. It's all same. Let's take the next one. So here also you have to start with the numbering to make sure this gets 1 position, 2 position and 3 position. Since there is no substituent group in this benzene, so we don't number it as such. So if you see at 1 I have phenyl group. That is the only substituent here because this is my chain, right? So let me add first the substituent. It is 1 phenyl. I'm done with the substituent. Correct. Then meth probe, and then at 1 position I have own group. So it's all single bond. Propane 1 own. Please note, probe is for 3 carbon, ane for all single bond in this chain. There is no double bond in this chain. Don't see the benzene, just see this part. There is no double bond, so it's all 1 ane. At 1 position I have double carboxyl group, so 1 own. This is how you name it. Let's take some more. So in this case also we have to write the IUPAC name. So let's number it 1, 2, 3, 4, 5. So if you see at 3 I have a aldehyde group. Here also I have carboxy group. Here also I have 1 carboxy group. So I'll take this as a primary one. I'll assume this guy is a substituent. It will be 3 at 3 position. I have oxy or oxo, 3 oxo. Total is 5 pent. All single bond ane. Aldehyde 1 al. So it is 3 oxopentanol, spentanol. Let's check this. Again, since it's symmetrical, so I can number from here to here or left to right, doesn't matter, it's all same. So it's symmetrical. If you see, you draw a line here, if you see the left hand side, right hand side, it's all same, it's all symmetrical. So now let's try to name this. So in this case, if you see at 2 and 4, there's a methyl group. So it will be 2,4-dimethyl. That means I'm done with my substituents. And now what I'm having is my chain. Chain has 5 carbon, so it's pent, all single bond, in. And the third 3 position I have ketone group, right? This is ketone. 3. Please note this was aldehyde because I have a hydrogen here. This ketone because both these sides has alkyl group. This is ketone. Let's see this. So here also if you see this is aldehyde, right? This is COH, aldehyde. For this, if you see, I have to number from here 1, 2, 3, 4, 5, 6. At 4 I have a nitro group attached. So it's 4-nitro is my substituent. And this is my benzaldehyde. You can say benzaldehyde directly, you can say. That is also fine because this is a accepted IUPAC name. Or if you want, you can say 4-nitrobenzene carbonaldehyde. Both are same. Let's take this example. I have my 3 carbonaldehyde group here, right? So what I can do is I can take this as my chain 1, 2, 3, and I'll say 1, 2, 3 at both all 3 position 1, 2 and 3 I have a carbonaldehyde. This is my probe, says probe, all single bond, in, and then at 1, 2, 3 I have carbonaldehyde, 1, 2, 3 carbonaldehyde. With tricarbonaldehyde. Why didn't I write this thing first, 1, 2, 3 tricarbonaldehyde propane? Because this is a more important group. So we have seen that if they are alkane, aldehydes and aldehydes gets more priority. So here I had alkane and aldehyde. Out of alkane and aldehyde, aldehyde gets more priority. So this becomes propane 1, 2, 3 tricarbonaldehyde. Let's take this. Let me draw this because when you draw this, you get a better picture. This is the structure. I have just removed all the hydrogens. So now if you see, this is my chain, the longest chain. Let me number it 1, 2, 3, 4, 5. So at 4th I have a methyl group, 4-methyl. I'm done with all my substituents. 5 carbon in the chain. It's pentane, all single bond, and it's aldehyde. Since there's one position only, I can just say pentanal, or I can say pentanal also. The next is this. Let me again draw the structure. This is my structure. So again, if you see the longest chain, 1, 2, 3, 4 my chain. There is no substituent, so I'll start with bute. There is a double bond at 2nd position, bute to ene, and at 1 position I have aldehyde, 1 al. Bute to ene, 1 al, or you can say bute to enal also. You can say you don't need 1 here because 1 is by default assumed position for aldehydes. Before I solve this, I want you guys to just pause this video for some time and try to solve this on your own and then see the solution. So I'll start with this solution. So let me draw the structure. 1, 2 carbon, and then I have a carbon here, this carbon, and this CH2, then again have a carbon, and there are 2 carbon methyl group attached, and I have a CO, and then I have a carbon here. This is my structure, and this is my longest chain. So I'll start the numbering from this direction. 1 is a ketone actually, you see. 1, 2, 3, 4, 5, 6. Correct. Now if you see at 3 I have 2 methyls and 5 I have a methyl. There are 3 substituents. So it is 3, 3, 5. Total 3 methyls, so trimethyl. I'm done with my substituent. How many carbon in the longest chain? 6. Hex. All single bond, A. And then in the ketones, I have to add on, but at what position? At 2. I have 2. At 2, I have on. This is 3, 3, 5 trimethyl hexane 2O. Correct. Let's draw the structure. It says that I have C6H4, that is, I have this guy, and then I have COH, this aldehyde, and at para position, I have CHO once again. This is the condition. So we number it 1, 2, 3, 4, 5, 6. At 1 and 4, I can number anyway, starting from this or this. You'll get same value because again it's a symmetrical compound. Correct? So the name of this compound will be what? It will be benzene. At 1 and 4 I have carbaldehyde, so it will be benzene 1,4 dicarbaldehyde. Why? Because this carbaldehyde is a primary group. Right? So it comes in the last. Let's check this. So let me draw the structure of this for clarity. 1 carbon, 2 carbon, third carbon with the oxygen. Then I have a carbon with the hydrogen here and a ethyl group here actually. Carbon with 2 hydrogen, carbon with 2 hydrogen. A chlorine. So this is also ketone if you see, right? This is a ketone because in this is my carboxyl group and there are 2 alkyl attached. So let's number this in this fashion that this get the lowest number. So the best way is to number in this fashion 1, 2, 3, 4, 5, 6. Correct? Because with this you get the least number. If you number in this fashion 1, 2, 3, 4, this gets 4 number. 1, 2, 3, this gets 3 numbers. This is a better way. Now let's start. How many substituents? There is one substituent here and then there's one here. So one is chlorine. So let me write chloro here. That is ethyl. Let me start now my English. A, B, C. C comes first, so chloro is first. At chloro is at 6th position, 6 chloro. And then I have ethyl at 4th position, 4 ethyl. Total number of, I'm done with the substituents. There are 6 carbons in this chain, hex, all single bond, and at 3 I have a ketone, 3O. The name of the compound is 4-chloro, 6-chloro, 4-ethyl, hexane, 3O. That is the name of this compound. Let's check this guy. Let's draw the structure first. Yeah, this is the structure. Now the numbering is I can do from this way 1, 2, 3, 4, 5. At 2 and 4 I am getting 1, 2, 3, 4, 5. 2 and 4 I am getting. The name is symmetrical. So we can number in any way. Doesn't matter. There is no substituent in this case. Again, my ketone is the primary group. So let's start with this. It's a 5 carbon, spent, all single bond, and then 2 and 4 I have a ketone. So I'll say 2,4 dione. 2,4 dione. Let's take some more examples. Again, here also I'll request you guys to pause the video and first try to solve on your own and then see the solution. Here we have to give both common name and IUPAC name, and common name obviously if exists, because common name doesn't exist for all the compounds. We know that. So let me first draw the structure of this compound. There's C, there's a carbon with the oxygen, then I have 4 carbon, and then I have CH3. This is the structure. So I'll number in this fashion to give the ketone group the least number. This is a ketone, right? Because this is a carbonyl group and I have 2 alkyl group attached to it. It's a ketone. So let's give the IUPAC name. So IUPAC name, there is no substituent. There are 7 carbon. It's hept. all single bond in. At second I have a ketone 2-on. That is my IUPAC name. Let's write the common name. For common name, what do? We just write the name of the alkyl group attached. So here I have a methyl and here I have a pentyl. Right? So I have a methyl, pentyl. Let's start with my ABCD, ABCD, EF, GH, IJ, KL, M come first. So it will be methyl and this is pentyl. In fact, this is N-pentyl because it's straight one. This is N-pentyl ketone. What do you use the word ketone? And this is my answer. This is for methyl, this is N-pentyl, and this is ketone. Right? Methyl N-pentyl ketone. This becomes a common name. Let's try this. I have C and then I have 5 carbon. 1, 2, 3, 4, 5, and then I have COH. This is aldehyde. Correct? Because in this is my carboxyl carbon and here I have hydrogen. This is aldehyde. So IUPAC name is pretty simple. Straight chain 1, 2, 3, 4, 5, 6, 7. 7 is heptanyl. And common name, there is no common name for this. As I told, common name doesn't exist for all the compounds. Let's try this. Here also, this is my aldehyde group, so this will be my number 1. Anyway, numbering doesn't make any sense because there is no substituent here. So if I want to write the IUPAC name, I have a cycloheptane, cyclopentane here. So first I'll use cyclopentane and then I'll use carbaldehyde. So it will be cyclopentane carbaldehyde. That will be the name. This is the last slide for the practice for common and IUPAC name. Here also again, please pause and try on your own and then try to see the solution. Let me draw the structure for this. 2 carbons and 1 carbon with the bromine. Then 1 carbon, this carbon has a methyl and then an aldehyde group. So this is my aldehyde. Correct? Now let's try to name this IUPAC. For IUPAC, numbering start from this carbon. So I have a substituent methyl and bromo. So I have a bromo and I have methyl. Let's start with my ABCD. A, B, B comes first. So it will be bromo first. At 4 I have bromo. 4 bromo. At 2 I have a methyl. 2 methyl. So I'm done with my substituents. Next I have 6 carbon in the chain. So it will hex. All single bond in and the aldehyde. You can give 1 al also. Or you can just ignore it also because if it is not given, assume that it's at position 1. The next is common name. Let's try the common name. This is my carbon, this is my alpha, this is my beta, this is my gamma. So at gamma I have bromo. Again same logic. Instead of 4 I'll say gamma bromo. 4 bromo. Instead of 4 bromo it's gamma bromo. Instead of 2 methyl it will be 2 alpha methyl. Gamma bromo alpha methyl. Right? And then we'll have, and this whole thing is called caproaldehyde. Caproaldehyde in the common name term. So you use this caproaldehyde. Next is this IUPAC name. See, there is no reason why it is called caproaldehyde. It is just called common name. There is not much logic behind it. Let's number it 1, 2, 3. So if I see at 3 I have a phenyl group, that is my substituent. So let me first add that 3 phenyl. And then I have 3 carbons in the chain, so it's pro. At 2 I have a double bond, 2 in, and then you can say al. Or you can say 1 al also, or you can just say al. So it's 3 methyl pro 2 in al. Want to write the common name? This is my alpha carbon, this is my beta carbon. And beta I have a phenyl group. This is beta phenyl. And this whole thing is called acrolein. We have seen that. This is beta phenyl acrolein. Let's check this. So here I have a 2-phenyl group. This is the structure. So we want to write the IUPAC name for this. So if you see there are 2 phenyls, diphenyl. There are 2 substituents. Only 1 carbon, so it's meth. It's the ketone, all single bond, and ketone on. So it is diphenyl with a non. Correct? Diphenyl is 2 substituents, and there's only 1 carbon, so it's meth, and ketone, so it's methanol. Let's write the common name. Common name for this is benzophenone. I think we have seen this. Why? We have told that if there is a phenyl group attached, this is called phenone, and there is a benzo group, this is benzophenone. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.